have flaws at some level. Einstein's theory of general relativity does not work at the quantum scale. It does not predict anything. So we know there's a mistake in it somewhere. We haven't figured out what it is, and that's what string theory is trying to do, unsuccessfully thus far. And so the multiverses, which assume there are infinite numbers of universes out there, some of them probably a lot like ours, are a good model to play with. They ultimately must be able to predict things. If their final answer is this is the way the universe is, tough, then I'm more than happy for someone to come up and say the universe is being carried away by 4 turtles, and that is equally good. I can do nothing with either of them as a scientist. So it must predict something, and I'm not saying those models won't predict something, but they don't right now.
OK， 他是说科学是很有趣的东西哈，但是科学需要实证。你可以发展理论，但是理论到最后还是需要实证。目前是找到这些实证。他说，就像爱因斯坦的相对论，相对论是很伟大的东西，但是相对论无法处理量子层级的现象。相对论到了量子层级，它就不能预测任何事情，所以他们相信说，爱因斯坦的相对论在某一个层面上还是有 flaw， 就是有错误的，还是有缺陷的。他说，许多宇宙从宇宙预测了好多无限宇宙出去，弦论就想弥补相对论在处理量子力学上面的错误。那就说你预测很多宇宙出去是没有问题啊，但是你没有办法证实。就像说，那我提出一个理论来，宇宙是被4只乌龟往外面拉，你也没有办法证实，因为2都是不能证实的理论。所以他希望是有人能够告诉他说，哪一天这个理论是可以被证实的。好，甘伟先生。
现在那个 M series 哈，这个跟这个有没有的进展之后 ？M series M 理论
That's 11 dimensions.
11 dimensions.
I understood the Chinese there.
Wonderful, you don't need me. 他说现在 M 理论11次方的11次元的理论。
So it's what about M theory? So M theory has an extra dimension compared to string theory, but it's the same basic idea. And for me, who understands string theory very poorly, and M theory even more poorly, they're effectively the same. They're the same basic ideas behind them.
那11次元的 M 理论跟10次元的弦论呢，基本上差不多的。他说他其实了解弦论了解的不多，所以了解11次元的更少，但对他来讲是差不多的东西。
The problem with 11 dimensions is that it's very complicated, but it also allows you to do almost anything you could possibly want to, because there is so much space to do things with. And so you can solve almost any problem in 11 dimensions, but it doesn't mean that it's correct.
Yeah, like free parameters.
Yeah.
基本上都是说11次元呢，你已经有那么多可以调整的东西，所以基本上你可以去解释任何的现象，因为你有太多自由参数可以随便你调整了，你都可以做出结果来，但是不具有任何太大的意义。好，我们刚好还有其他的问题是吗？
老师你好，那个我只是有个小问题，就是说，像那个刚才有讲到说暗物质，它那个一直都是存在的，它是固定的。那我是想说，所以它是代表说，在那个 Big Bang 的时候，那个暗物质基本上它就从 Big Bang 里面出来的吗？还是会不会就是目前就是暗物质跟那个 Big Bang 的理论有没有什么样的那个违背或者是那个差别还呀？那我另外一个问题就是说，那刚才有讲到暗能量，暗能量你说它会随着时间跟空间会增多，那如果增多的话，那我可以说是因为暗能量的原因，所以导致说它创造空间，我可以这样说吗？
Okay, a very interesting question. First one is dark matter. What is the origin of dark matter? Does it happen that it is created when the Big Bang happened?
So it would have been formed in much the same way that the protons and electrons in our body were formed. We're pretty sure that if dark matter is a particle, it is much heavier than a proton, and so it was formed closer to the Big Bang. Protons were formed about 1,000th of a second after the Big Bang, and we think that these things would have had to have been formed somewhere between 100,000th of a second and 1 billionth of a second after the Big Bang.
OK， 但是暗物质应该是比质子还要重的粒子，质子是在 Big Bang 发生之后的1/1000秒左右形成的，所以这种粒子呢，可能是在10万分之一到10亿分之一秒左右形成的，比质子还要更早形成的。
Yeah, the heavier the particle, the closer to the Big Bang it was formed.
Yeah， 越重的粒子是越接近那个 Big Bang 的开始的。Okay, and the second question from her is the dark energy. That in your talk, dark energy is tied to the space-time structure. So as the space-time expands, it gets created. But she asks, is it possible that the other way around, that the dark energy causes the creation or the expansion of space-time?
Okay, that's interesting. To my mind, that's sort of the same thing. And so the dark energy causes space to be created faster and faster. But since it's tied to space, it's sort of circular. But that's what exactly causes the universe to expand faster and faster. It's the fact that it sort of creates itself.
Yeah， 它自己产生自己，就说暗能量跟空间、时间绑在一起，那谁产生了谁其实没太大的差别，他们就是一同发展出去，让宇宙加速的。Yeah. But I guess in our impression that dark matter, because it reveals the fact of gravity, 暗物质有重力的性质 ，so somehow it should be some simpler than the understanding of the nature of dark energy. But it seems to me that in the past 10, 20 years, we didn't get too far in understanding dark matter.
So we haven't, so dark matter, I think, is easier than dark energy if it's a particle.
Okay.
If dark matter is not a particle, then we're in trouble because we have no idea what it is. But if it is a particle, we just have not been able to make an accelerator big enough to find it. And it may well be there's a hint of a satellite which may see dark matter crashing into itself and producing a positron and an electron. A positron is antimatter, an electron is normal matter. So it's the antimatter particle to electrons. And there seem to be a lot more of those running around near the Earth than you might otherwise expect. And so people are extremely excited to see if this experiment is confirmed and whether or not we can trace it to being this dark matter.
对，他说暗物质其实听起来应该是比暗能量来得简单一点，因为它是比较接近我们熟悉的物质的。但到现在为止呢，也还是没有太多的发现。但是很希望是说，如果哪一天看到2个暗物质的粒子，因为他希望暗物质是粒子，如果不是粒子的话，那我们根本就不知道它什么东西，那我们就麻烦大了。那如果是粒子的话，它撞在一起呢，可能会像正常的粒子一样产生一个正子跟一个电子。如果你有那样的结论，马上可以从正子跟电子的能量推估出来暗物质是多大的东西。那现在可能是地球旁边有很多这些暗物质飞来飞去，我们是完全不知道的。那希望有一天能够做到这样子的测试。呀，还有其他的？
请问你啊，那个 Big Bang 的能量从哪里获得的？
Where does the energy for Big Bang come from?
I don't know. We know science cannot tell us everything, in my opinion. There are those who disagree. But why the universe started, we don't know. And so I still think there is room for those who like religion to use religion there. But you don't have to have religion. You can just accept you don't know. So the answer is we do not know.
当然是我们不知道。说你是宗教可以介入的空间，如果你喜欢宗教的话，但是也不需要宗教，就是坦白承认我们就不知道就是了。
Some people think it